Okay, good afternoon everybody. Thank you very much Phil, for that. That's fantastic, and learned lots of great information that I'm going to take back to my school. I'm from Coventry Lane Primary School in North Manchester. I came down yesterday and yeah, not feeling 100%, but I'm enjoying being here and having discussions already with people over coffee about all the great work that's going on as schools think about transitioning from ICT to computing. So what I'm going to do, just for kind of 20 minutes or so, is just talk about what we've done at Coventry Lane Primary School. I'm going to go through our computing curriculum. I'm a Year 5 class teacher there, I'm a computing leader there as well, and I run a blog, Primary Computing, and put lots of resources on there to support schools. I'm also on Twitter as @DrChips_. I really recommend going on Twitter as a source of professional development. I would like to have had @DrChips, but @DrChips is actually an aspiring American teenage rapper. So if you search @DrChips and you get him, that's not me. So please do add the underscore. Okay, so I'm just going to talk through what our computing curriculum looks like at Coventry Lane. And Phil's focused very much there on the kind of computer science element and the programming. I'm going to take it a bit wider than that. Because as Phil said, it's not about doing everything new and getting rid of what we were doing before. It's a kind of chance to evolve what we were doing before, and then we have this kind of revolution part as well, perhaps with modern computer science. Everything I talked through is available to download as well from our school website, which is coventryllaneprimary.org, so just to make you aware of that. So what we did is we started with a draft of the national curriculum document that was coming out about 18 months ago, and from that we decided that we would have a 5-strand computing curriculum, and you can see the titles of the 5 strands there. So those 5 strands kind of give us the breadth to cover both our IT and digital literacy as well as the computer science. So we've got a multimedia strand, we've got our e-safety, data, programming, and an online strand. And what I'm going to do is I'm going to talk through, sort of in a bit more detail, what's covered in 3 of those, multimedia, programming, online. I'm going to touch on e-safety as well. And I'm going to talk about how we're kind of as well looking at what we're already doing and how we can perhaps just put more of a computer science slant on the IT work that we're already doing. So I'll kind of mention that a bit more when we talk through the online strand. So just to make a start with multimedia, we very much have taken an embedded approach in targeting the skills in our multimedia strand. So we use something called the Focus Education Learning Challenge Curriculum at Coventry Lane. I don't know if anyone here uses that, or sort of, I can see a couple of nods. So the idea of that curriculum is that there is a kind of large learning challenge, such as Were the Vikings Really That Vicious, that pupils work towards answering over the course of a half term. And an important aspect of the Learning Challenge curriculum is having an output activity, an outcome. And we often use, we make that output activity, that outcome, something like an animation, a video, a podcast. So we are targeting those IT and digital literacy skills within our creative curriculum. Sorry, I'm just going to go back one and say that what we did after we settled on those 5 areas of curriculums for our curriculum is then wrote skills progressions, and there's a screenshot there for each of those areas. You can see the screenshot is for Year 5. So when I talk about the skills that the teachers are targeting, that's the document that they work from. These are the different media types that we cover in multimedia. You can see there graphics, text, digital audio, video and animation. And we revisit the media types at least twice, with text 3 times over the course of pupils' journeys through Key Stage 1 and Key Stage 2 so that we can show progression. And talking about progression, can I just get a show of hands who has tablet devices in their school, whether it be iPads or other tablets, right? So a large portion. And Newcastle, can I ask you to do the same for me, please? Yeah, about the same. So lots of people in Newcastle, lots of people here. Thank you very much. So one thing we noted, a kind of trend that we noted, was that there are lots of apps being made available of software packages on tablet devices, and the apps are kind of cut down in terms of their functionality, and they provide the learner with quite a scaffolded approach. So a great example is iMovie. So we use the iMovie app with younger pupils on our iPads, and then when they revisit the kind of video unit in Key Stage 2, they will then move on to kind of the full iMovie package on the Macs that we have. And there are other apps which sort of do similar. So we use the iCanAnimate app again in Key Stage 1, and then pupils move on to the iCanAnimate full software package. I'll put a note on there, CS Focus as well, talking about this transition from ICT to computing. We do also, when we're sort of doing these projects, and they're kind of IT projects, generating these digital content, creating these videos, we are building in a bit of computer science focus, looking at file formats, looking at file sizes, transferring files from one device to another. When we set about kind of revising our e-safety curriculum, when we looked at what we were doing in school, we felt that there were a lot of e-safety resources out there, but we didn't have a kind of a progression of skills and knowledge that we want pupils to develop in school. And I was very fortunate to come across and be sent an excellent piece of work developed by the Oldham City Learning Centre, and this is incorporated into the skills progressions which are available to download from the school's website if you want to have a look at this. It's a 3-strand e-safety curriculum that focuses around critical thinking and discernment, socialisation and ethics, and self-protection and personal skills. So that we've now got a progressive, clear, comprehensive e-safety curriculum in place, which is running throughout the year with all pupils in all classes. If I move on to online, the main piece of work, and it's a work in progress, very much a work in progress, that we're doing here, is, as I say, going on this journey from pupils being able to use technology to really understanding how that technology works. So what we did is we looked at the previous units we were kind of doing in our online strands, such as using websites, email, blogging, etc., and then thought about how we can incorporate the computer science focus. So with the websites unit, we are starting to develop lessons, and I will be watching back on the session that I missed on the internet and World Wide Web, etc., and networking, because we're developing lessons around that for the pupils, so they're not just using websites, but they're understanding how they are created and hosted, etc. With emails, we talk to children about emails journeys, the journeys that they go on, and look at the structure of email addresses, etc. We've had a real success in the school with blogging. All of the class teachers have run blogs for their classes, and we're quite fortunate. We have quite a few iPads in the school, and all the teachers have iPads, and we use WordPress for our blogs, and we found that really kind of streamlined the process for blogging for the teachers, because they could have the WordPress app on their iPad. At the point of learning, they could take photos of what's happening in the class and then send it up to the blogs. And that was a real success in getting pupils onto the blogs and commenting on the learning outside of school hours. And then the pupils said, well, we want our blogs as well. So we set up pupils' blogs with kidvlog.org. That's free to use. That's built in WordPress as well. So all year 5 and 6 have their own blogs. But now what we're doing, again thinking about this moving from just using technology to understanding it, when we're getting them to do blog posts, you can set it so you're looking at the HTML mode. If you're embedding pictures or embedding movies, you get that code that you can copy and paste in. And so pupils are starting to develop their understanding of the computer science, as well as just how to effectively use that software. Internet research, again, going from just using Google to understanding how it works and how it ranks. We did an unplugged activity around that, whereby I was getting pupils in their groups to generate web pages on flipchart paper, and they could link to each other's by writing a little L on a post-it and just linking across. And then we kind of revealed a criteria which we would say Google would use to kind of rank pages, and we set it up as a competition. And we saw which web page would rank the highest. There's materials that kind of support lesson planning around that on the CAS website, Computing at School. That's certainly where I got the idea from, and also from Phil's Codit website. We also wanted to introduce pupils to the concept of cloud computing. So I think it's a really important shift to kind of understand that more and more devices such as your phone or your iPad or your laptop are kind of gateway devices. Rather than information just being stored there, they're stored elsewhere. So using Dropbox, we set up a free Dropbox account, and we're encouraging pupils to upload to it in school, work on documents at home, and vice versa. You could do the same with Google Docs. So, moving on and spending a bit more time talking about our programming curriculum. We have programming as a lead subject for 2 half terms, so pupils have an hour and a half programming for those 2 half terms. We use a range of apps and programs, although picking up on the point that Phil made about perhaps sort of selecting and slimming down. Certainly I agree, and when I talk about sort of what we're doing now on Key Stage 2, we've really slimmed down to just using Kodu and Scratch. The document that Phil Pinchton held up, the colourful one from CAS, the Guide to Primary, can I borrow it again, thank you? I'm just going to say again how valuable this is in terms of planning your curriculum. And another document as well to kind of go along with this, which I found really useful to look at, I shall return that in 1 second, sorry, is one from CAS called A Curriculum for Schools. If you Google CAS, A Curriculum for Schools, there's a document that comes up that was written, I think, published during more of the consultation period. And it goes into a bit more depth on, well, it's just, there's kind of content in there which isn't necessarily covered in here and vice versa. And I find it useful to look at. So programming at Key Stage 1 at Cromston Lane Primary School starts with lots of unplugged activities. There we are, decomposing daily tasks, as Bill has mentioned. And we then move on to using apps such as Daisy the Dinosaur, the Bebots, fantastic session happening today about Bebots and Beyond, and the Bebot app there as well. And the focus is very much on the kind of computational thinking skills of decomposition, algorithmic thinking, abstraction, so the concept of removing information which is not important, not necessary to solve a problem. Key Stage 2, lower Key Stage 2 we do some work with Kodu. With Kodu, all of Kodu is programmed in these kind of selection frames. When this happens, do this. So that's fantastic for introducing the concept of selection, whereby when a certain condition is met, then parts of an algorithm or certain commands are run. The whole of Kodu, just a sort of point to note as well, the whole of Kodu constantly runs in a kind of forever loop, as was mentioned before, the idea of these loops. So, because that's the case, you don't have to kind of choose what elements of your program you want to loop over. So, in a way, it's kind of a bit more of a scaffolded experience for the learner, because you don't need to make these decisions about when I'm going to use selection, when I'm going to use repetition. Repetition is happening all the time, and you have to build the programs using selection. So moving on to Scratch in sort of years 5 and 6 kind of removes that scaffold. Scratch is incredibly open-ended, as Phil was saying. You can go right on up to degree level with it. And we've just settled on Scratch. We do a project in year 5 using the Raspberry Pis. Can I just get a show of hands who's had a go on a Raspberry Pi? Right, brilliant, quite a few. So There's a gentleman called Simon Walters on Twitter who was talking about this. I don't know what the correct terminology is, whether it's a hack that he's done from scratch or a modification, but this modification of scratch, you can download it from his blog there, will operate the output pins, so you can send voltages to motors, and we use that for our kind of control. We do a sort of robot wars unit. So if you've got Raspberry Pis in school, then that's perhaps an option as opposed to the Lego We Do stuff. The Lego We Do is fantastic as well, but there's just another option there that you could perhaps pursue. Just to very briefly provide a reflection on my experiences of doing Python. Last summer I wrote a scheme of work for Python to trial with Upper Key Stage 2. So Python isn't a drag and drop block building language like Scratch or Coda. You have to write in the lines of code. I wouldn't say to anyone, do this or do that, but personally, I'm not going to pursue trying to do Python at the moment with my Year 6s, because what I found is that the complexity of trying to write in the lines of code is a kind of stumbling block and a barrier to the learning about the programming. And the problems, you know, as Phil said, this comes back to problem solving, what we're doing here. The problems I was giving my Year 6s were a lot simpler than they were doing previously, just because I'd made the kind of programming language and environment more complex. So I might come back to that in a bit, and I've got lots of resources for Python on primary computing, but just to sort of share that with you, I think for the moment I'm going to stick with Scratch for Upper Key Stage 2. Just to mention briefly then, finally, about what we do for assessment, because I know that at the moment schools are starting to think about what they're going to do for assessment. The planning document, the skills progressions that I showed you at the start that we developed around the 5 strands, we use as a planning and assessment tool. So we mark onto those against the various learning objectives, those pupils which exceeded or those pupils which were working towards those objectives. And we put together with that evidence of screenshots, photographs, quotes, etc. So teachers are just writing on the names of pupils which were exceeding or working towards. The majority of the classes, they don't appear on their assumed working at. I had an interesting conversation with Emma a couple of weeks ago about, however, when can we say that they are exceeding and they're working at. What we've tried to focus on now at Clumpsall Lane is making sure that the programming is a creative experience whereby pupils can problem solve, you give them challenges and you let them demonstrate their capacity to apply the skills that they are developing. I think it's about sort of going on a journey in terms of getting programming into primary schools and getting teachers confident in delivering programming lessons. And I think initially to do that we might provide more scaffolded, structured lessons whereby pupils are sort of working towards more similar outcomes. But I think to really understand how well pupils understand these concepts, you need to enable them to apply those skills in their own ideas, in their own projects, and that's what we're working on at the moment. The document to the right here, I don't know if people have seen that today, this morning. That's a progressions pathways developed by CAS, and at the moment I think it's a really important document to look at. It looks at progression in kind of the computer science, the programming side, algorithms, algorithmic thinking, also the hardware side, the networking side of things as well. It's not leveled with numbers, but you do have the banding of different colours, and what we're doing at the moment, we're using that document as a kind of reference point to check that we are doing everything with our pupils to kind of get them to the expected level that's kind of being sort of defined for where we want to get them to in primary schools. So, that is me. I hope that was useful. So it's just a case that it's very much a work in progress for us, but it's just an opportunity to share with you what we're doing, our 5 strands, just reinforce the message that it's not all new. We're still doing our ICT. We've evolved it a bit to incorporate computer science. And please do get in touch via Prime Computing or Twitter, remember the underscore bits if you're on Twitter. And if I can help in any way at all after today, I will do. Thank you very much.